Hi, everyone. Buen día. Buenos días a todos y todas. Maybe you have a screen. Yes. Hi, I'm Daniel. I work in Broadcom with the Spring commercial team. So I do a little bit of open source Spring on the Spring security side and anything that is Spring security related. And in Tanzu, I do applied Spring. We take Spring, we build products with it, we package them, and we sell that to customers. And I'm just building on the shoulders of giants where we stand, right? Just like you're using Spring, I'm using Spring. And I want to pay respect to all the people who contribute and the people that were here before me. And before me here, I think it was Dr. Venkat. So to pay my respect for Dr. Subramanian, I'm going to take my shoes off. Venkat, this is for you. OK. Contact information, I'll give it after. Shoot me an email, a message, a question, grab me at a conference. I'm here to interact with the community. It's going to be fun. So we're here to talk about Spring security. Before we start this, I always ask the question in here. I kind of know the answer, I think. Who uses Spring Boot here in the room? That is 99.99%. And who likes using Spring Boot because it's nice and easy? Yes, the same. Everyone, 99%. And who here in the room uses Spring security? Wow, like probably 80%. Who here likes using Spring security because it's nice and easy? Wow, that's more hands than I usually get. So, yeah, probably 15% of the people in the room. And it's a normal, if you haven't raised your hand, it's normal. We're used to it. When I go to conferences and I sneak up on people and ask them, do you have a minute to talk about Spring security? Usually they have a little bit of tension coming in and, well, Spring security is so complicated. I don't understand how it works. And, the other day I had to do something. I went to Stack Overflow. I copied some stuff. It didn't even compile. And when it compiled, I got some weird error messages. So, I'm burned out by this. I have this old config that I have to update because I have new features that I need to add. So, I tried, but it's very scary and overall confusing, right? And we are aware of this. And we even have some section in the reference docs that says that. I have a complex scenario, what could be wrong? And we say you need an understanding of the technologies you use before you can go and build applications with them. So security in general, not just Spring security, but security in general is complicated. And setting up something simple, so like form login, is straightforward. You can copy the guide, it works. However, if you try and jump straight to a complicated use case or scenario, you are almost certain to be frustrated, like 75% of the room that didn't raise their hands. So you need to take things one step at a time. Good news for you, there are not many concepts that you need to understand to be more proficient with Spring security. And so that's my goal today. I want to give you the keys you need to understand how to build something with Spring security, not show you like a demo of all the cool features you can have, everything that's bundled, but give you an entry point to understanding how it works so you can extend it and build your own use cases. And hopefully, after this talk, you'll go from this to this, and you come talk to me, and I'll be very happy. So, I like to start with a demo. It's a short session. The first time I did something around this was at Devox, and it was 3 hours. So I had to compress it a little bit. I'm not going to be live coding this. We're going to start from existing applications, and I'm going to introduce the 3 important concepts that you need to know, and have a tangent about configurers in the end. We can't cover everything, all of Spring security in 50 minutes, and even 3 hours is a bit too long. So we're going to be focusing on a few things. First, we're going to be doing servlet, so Spring MVC, not reactive. If you understand MVC, you can easily transpose that to reactive. It's slightly simpler. Second is Spring security does 3 things. It does protection against exploits. It does, which we'll talk about a little bit. It does authentication, so knowing who the user is. I'm Daniel, my email is this, my birthday, and so on. And 3, it does authorization, permissions, which you need to know the user before knowing their permissions. And we're going to focus on protection against exploits, authentication, and authorization, maybe next year. We'll see. All right, so a little bit of a demo. A very basic app, very simple, that's running here. It has a public page. So when I click on go to private, it tries to go to /private, and then you get the default login screen that you're used to, and you can log in with a username and a password. Amazing. And you can also log in with Google. So I implemented OpenID Connect login. So in here, I have to use my work account to log in with Google. So Google redirects me to my SSO provider. Hello, Okta. The fine folks at Auth0 will be very happy to see this. OK, I can log in. Then this one, once it's done, should redirect me to Google. And then Google is like, yeah, OK, fine. Do you want to trust this application? I trust the application. And I'm logged in, and I see my email address. Very simple. You can build that easily by following the tutorials and guides you have on the internet. How does it work? What are the important bits in this application? First, in the dependencies, I have the Spring Boot Starter security, which allows me to do form login, and then OAuth2 client, which allows me to do login with SSO with Google. Since I'm using Google, ready your cameras here in my application here, I have some secret credentials. Look at them, look at them. Oh, here they come. Ah! Right? And then I have configuration. So in the past, when you configured Spring Security, you used to do security config extends web, security configure adapter, which doesn't work anymore. That was Spring Security 5. Now, in the version 6, you configure Spring Security by having a configuration class. You provide a bean of type security filter chain, which is built from the same builder you had in the past, so HTTP security. In this builder, you do a few things. One, you say what you want to protect and how. So in here, we're saying, any request must be authenticated. You must be logged in to see anything, except these, which are permit all. So the main page, the CSS, the favicon, whatever. And that's a pattern we use in Spring Security and that you should be using in your applications as well, which is secure by default. So if tomorrow I add a /spring.io endpoint, by default, it's secured. And I will realize I need to make it public, but I'm not starting to leak information without realizing. So that's what I want to secure and how. And then there's how do I want to log in. So I want to enable form login, and I want to enable OAuth2 login as well. In the past, you used to be able to configure this with this Fluent API. So you could say request matchers, Spring, IO, permit all, and then any request authenticated, and something like this. And this caused a lot of confusion and frustration, and people would be like, oh, help me. So we decided to do away with this. Now, if you go and look at this method, it tells you it's deprecated. Do not use this. Instead, all of this code that you had, you're going to take it and put it in a lambda that you have here, right? So now at least you know the scope of what you're doing. It's scope to this. Sometimes people are confused with this with defaults here, which we can qualify, customizer with defaults. It's not super, it's not rocket science. If I inline this, it's just a lambda that does nothing, right? There's no magic here. You can write this on your own if you will. This is just syntactic sugar. All right, so we have configured security, and then we can also use the outputs of Spring Security. So in my controller, I have a public page, and I have a private page. And on a private page, I can inject an authentication object. And from this authentication object, I can get either the name or the email, depending on how I log it, right? That's it. So we have a basis, and we can build something with it. So the question now is, what does Spring Security use to provide all of these features that I've shown you? The first, the most important building block, is the filter. It's the thing that allows you to interact with HTTP, requests and responses. So it has an interface it's an interface, and it has one method like this that's called doFilter. It takes the request object, the response object, and the filter chain. Remember the security filter chain we've seen. And they all kind of work the same. First, they inspect the request object. They make a security decision. Oh, this looks like an attack. I'm going to block it. Or this looks fine. Let it through. Then they invoke the rest of the chain. And then sometimes after chain invocation, they do a little bit of cleanup. And so that's not a Spring Security concept. That's a servlet concept. So in your Tomcat, there is a filter chain. We have a specialized one, which is the security filter chain, where we put all the security-related filters. And a filter chain kind of looks like this. You have the request coming in, and it goes through the filters in order. It's not a for loop, because we go through the filters. At the bottom, we get to the thing that does the business logic. So if you're doing servlet, this would be your servlet, basically. If you're doing Spring, it will be your controller method. Once we're done, we go back up through the filters in reverse order. And this is done by implementing kind of look like this. This is in green. This is a request comes in, and we create an instance of the security filter chain. We call do-filter on it, and then in do-filter, it's going to increment the position, so start at 1, say, right? And then it's going to find filter number 1, which is here. It's going to execute it, and then filter number 1 calls back into the chain. And so when we get to the second invocation, then in here, the position increments again, then we call the second filter, and then we get to filter number 2, which calls the chain, and so on. So the stack trace kind of looks like this in the end, right? There's the filter chain, which calls the filter 1. Filter 1 processes the request, calls back to the parent filter chain. The filter chain calls filter 2, which calls back, and so on. And then once the request has been processed, we go back out of this. And so that's why you have these very, very, very scary stack traces, where you have 5 bajillion times do filter. It's fine. It's just the filters that happened in the past. The one you care about is the one at the top, basically. This is where you want to put your breakpoint. Okay, so now we know how filters work, so let's implement one. Let's make a use case where we do a security decision based on an HTTP request. So we can add a class here. We're in Spain, so I'm going to call it prohibido filter, right? And it must implement filter. So the filter you want is not the logging, it's the servlet one. And if you do this, and you tell IntelliJ implement the methods, you'll realize you have 3 methods to go through and think a little bit. So our recommendation for this is don't go into the Jakarta, the JDK world. Stay in the nice, comforting Spring world, where we give you a once per request filter. And this once per request filter has 1 method. It doesn't have these init and destroy, so I don't have to think about lifecycle. And it's called do-filter internal, but basically, do-filter internal, same thing. So it takes a request response, a filter chain. For now, we're going to log. Make sure we call it es prohibido, and that's it. And then I need to register this filter in my filter chain. So we go back to the security configuration here, and we can say add filter. And in add filter here, it shows me, do you want to put it before something, after something? Because the order is really important. If you try add filter simple like this, it will reject your request or your registration because it doesn't know where to put it. So add filter before. Basically, for what we're going to do and for most of the work you will do yourself, you can kind of put it anywhere you want before any filter you know. What's important is that it comes before authorization filter.class. So authorization filter is the filter that does this. And it's important that your filter come before this, because if you're logging a user in, for example, they need to be logged in before you can check their permissions, right? So a good first approximation, register your filter before authorization filter. Now, if I go here and I make an HTTP request here, right? And then I look at my logs, es prohibido. So we are calling that filter indeed. There's a little problem with my filter, though. If I try and go to the login page, I get a blank screen, which is sad and broken. So if you've been following, what's the problem with my filter here? Yeah, the chain, right? You have to call back into the filter chain. Otherwise, nothing processes the request. You don't get to the controller that renders the template. So filter chain, request response. Go here, refresh, it works. And then in my logs, I have a bunch of logs, right, because I'm loading the controller method and then the CSS. Okay, so it's a filter. It's running when a request comes in, so let's make a security decision for this. And so to make a security decision, we can look at the headers, because it's easy to demo. And we're going to look for a custom header, so it's X, because it's custom, X prohibido. And when it's equals to C, then reject the request. I'm going to use object equals here. How do we reject the request? We write to the response. So I take the response object here, and I set the status to, I'm going to use HTTP status, this one, forbidden, and then I can write to the response. I can get the writer, and then write, and then here, right, es prohibido. And then I return, because I don't want to execute the rest of the chain. This is rejecting the request or doing the rest of the filter chain. Since I'm being cute with my emojis and all, I do have to do a little bit of a boilerplate to set the character encoding to UTF-8. Yeah, that's good. And then also a header, maybe. Content type. Let's say text plain char set equals UTF-8. Good. All right. So now, when I make an HTTP request, if I do HTTP AT X prohibido, and then C, then it tells me es prohibido. If I give it a no es prohibido, then I get the public page. And if I give nothing, it's basically what's happening in my header, nothing happens, right? So in here, this still works. I can still log in, user password. There we go. And so why is this important? That's because all of Spring Security is implemented like this. So the entry point to processing HTTP requests is a filter. So here's an example, CSRF filter, cross-site request forgery. So I don't want to get too deep into the details of CSRF protection. So basically, it's a thing to make you do requests and not realize you're making them. So like phishing attacks where you click on the image and it posts a form. And you basically block this type of request with a token that you put in your form, so CSRF token, and it's matched against what's in your session. And so how does that work in Spring Security? Let's take a look at the CSRF filter. There we are. So as I told you, it's the magic, once per request filter, this one, okay? And it has a do-filter internal method, so it does a little bit of setup, fine. And then it says, does this request require CSRF protection? Is it a post or a put or a delete request? If it's a get, I don't need to protect. So if it's a get or a trace or a head, then just say, it's fine. I don't need to do anything here. Call the rest of the filter chain and return. Then if the request does need protection, because it's a form, it's going to get the token from the session. It's going to get the token from the request, from the body of the form, or from a header. It has many ways of doing things. And it's going to compare these two tokens with additional protections against timing attacks and so on. If they are not equal, then it creates an access deny exception, maybe a missing token, maybe an invalid token. And then it's going to call into this access denied handler, which ultimately did what we did, right? It says HTTP status forbidden 403. If it's not denied, if the tokens are equal, it's a fine request. Let it through. So this shows two things. It shows that you can implement this yourself, and we've done it. It's easy. It's not super hard to understand. The second thing it shows is that the security behind it is a little bit complicated. If I want to go into the CSRF filter and change the request handler, I kind of have to understand how CSRF work. What is the CSRF attack? What protections are in place? What do I need to, if I want to touch something, how does that fit into the global protection scheme? Okay, so we have a filter. We know it looks like Spring Security filters. What if you want to discover more of the Spring Security filters that are registered and protecting your applications? So the first thing you can do is look at the logs, and when your Spring Boot app starts, you look for the biggest log, the one that has a lot of black text here, very scary. And it says here, default security filter chain will secure any request with disable encode URL filter, web async manager integration filter, blah, 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 CSRF filter, and so on, and then all the way to the bottom, prohibido filter, and then authorization filter, which is the last one in the chain we used here. So now we have the config. We know all the things that go into our filter chain. But that's very static. That's like, how is it set up? If you want to learn more about filters as they are executed, I'm going to give you the #1 trick, the one thing you need to remember from this presentation. I'm going to make you a Spring Security expert. You set the logging level to org, Spring Framework, security, all of security to trace. And voila, you are a Spring Security ninja now. Ninja. Amazing. So maybe you don't want to trace in production, but most of the time that's really good. Okay, take the logs here, clean them up, unwrap. So if I make a request with prohibido C, it gets rejected, right? 403 es prohibido. And we have a lot of trace logs. So we can go here. It tells you, I got a get request on slash, and now I'm invoking the first filter in the chain, the disable encoder filter. Then the second one, then the csurf filter. And the csurf filter itself tells you, I didn't apply csurf here because it was one of these methods. It was a get here in this case. And then all the way to the prohibido filter that gives you number 17 out of 18. And we don't get the authorization filter. We don't get 18 out of 18. So if you have a problem, your requests are rejected, you should start looking here, because that is the filter that is rejecting your requests. And with this, you will be able to debug everything, and your team will love you. Send me roses, because you're super happy. I'm going to remove this because it makes a lot of noise. All right, so filters, default security filter chain, or logging, level, org, Spring Framework, security, trace. Very good. So a little recap of what we did. We looked at the basic filter interface. Specifically, the one you want is once per request filter. There are other things, but 99% of the time you want a once per request filter. It takes the HTTP request, the HTTP response, it reads the request and makes a security decision. Oh, this looks like an attack. And then it writes to the response saying, I reject this, or it does nothing, or it writes something, a log or to the context. And if the request is secured according to the filter, it calls the rest of the filter chain. It says, filter chain, do filter. These filters, they go into a security filter chain. So everything that is security related will be in the security filter chain. When you do your own, put them before authorization filter.class. All right. So all of this shows something like csurf protection and cross-site scripting and so on. But it doesn't really tell you how you can log in, right? So when I type my username and my password, and when I use Google, I log in. And what Spring Security does is that it produces an authentication object. So the authentication object it's an interface. And this interface is used for two things. It's used for authentication, so identifying who the user is. It's Daniel. He's 36. He likes bananas, apparently. And it's also used for authorization. So authorization is permissions. Is Daniel allowed to go to the admin panel? Is Daniel allowed to delete order number 123? So we're focusing on the first one in this presentation, but you need both, and they're both in this authentication object. It's represented in the authentication interface with the principal. The principal is the user, the entity making the request, the identity information, and authorities. Authorities are the roles, the permissions, the scopes, anything you use for authorization. So when we look at one of these authentication objects, or at the interface, it has getPrincipal method here that returns an object. We know Spring Security is not the most type-safe library in the world. You will be casting stuff often, but it comes from a long, 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 long time ago. So that's what you have. Please do not confuse the getPrincipal with this principal here. So the authentication interface extends the principal interface. The principal interface is the Java security way of representing a user. Don't look at this. It's fine. Stay in the Spring world. It's comforting. So authentication object, and you get a principal. In the authentication interface, you have a bunch of other things. So there's a method that tells you is authenticated. When you configure your filter chain so that every request is authenticated, well, is authenticated is always going to be true. There are details, usually the HTTP, the IP of the client that made the request, and credentials. Credentials, when you get an authentication object in your controller, credentials will be null. That's because credentials are a security concern, not a business logic concern. And we don't want you to take the user object and then log it to the console and then have the token in plain text. So it will be erased for you, and credentials will be null. And these authentication objects are stored in the security context. So there's a security context holder class that has a getContext method, static method, returns a security context which contains the authentication. So basically, in our controller, we injected the authentication object, but you could get it from the security context holder, getContext, getAuthentication. That's an auth object, and here auth is strictly equals to authentication. So this might be useful to you When you have a very deeply nested tree of dependencies, you have a service that calls a service, that calls a service, that calls a service, and then you want to do a security check at the bottom without injecting the authentication all the way through, you can get it with the security context. It's also how Spring Security can do stuff like, nope, not click on this. It can do stuff like pre-authorize, so method security, has role admin. It's going to get the authentication from the context and then compare the roles to this expression here. We've learned in school, don't do static, it's bad, global state. It's not truly global state, it's only valid for the request that's happening. It's a thread local global variable. So if I have two requests in parallel, they have their own security context, they're isolated, it's safe, you'll be fine. If you're sending work to other threads, then you will lose this, because it's only global to the request thread. Okay. All right, a little quiz for you. What's the most common authentication implementation that you know? Basic? All right, but the authentication class, the one that you use everywhere. Yeah, password. Username, password, authentication token. Do not use username, password, authentication token if you don't have a username and a password. There are plenty implementations of authentication that represent different things. And this is a common mistake when people start with Spring Security, because they start with form login, so they can log in with their username and password, and then they debug, and they see this username, password, authentication token, and they're like, yes, I'm going to use this. Please don't, right? This authentication has a bunch of other implementations. There's like one for testing, there's stuff about OAuth 2, and so if you don't have a username and password, use a specialized implementation of that. So let's do this. Remember our chain, we said do filter, request, response, we do a security decision. When you're authenticating a request, it kind of looks like this instead. So first, you decide whether you should be applying the filter or not. Second, you get the credentials and you validate them. And if they're valid, you create an authentication object. If they're not valid, you reject the request. Then you invoke the rest of the chain, and then you do no cleanup, because cleanup is kind of a very edge case. And we'll do it in the framework, but you usually don't need it. So let's implement a use case for that. Our app is great, right? It has a public page, a private page, and the SRE team comes to me and they say, Daniel, we want to check the contents of the private page every night. So one thing they could do is they could write a Python script that goes to the form, and then it parses the form to get the CSRF token, makes a post request, extracts the session cookie, or the driver browser. So not great. Let's pretend there's no solution that already exists, and let's make something for them. So we always do this with a filter. So we start with a filter here, and we're going to call it robot authentication filter, right? And we said it extends once per request filter. Amazing. We said what? We said one, decide whether we want to apply the filter question mark. Two, check credentials and authenticate or reject the request. And then three, call next. And so next is the easy part. Filter chain, do filter, request, response, fine. And then nothing. So we take this filter, we register it in our security config. Say it's called a robot authentication filter. Amazing. I'm going to leave this aside for a while, and then we're going to do this. So for credentials, again, we're going to do headers because it's easy to demo. A new header called xRobotSecret, and when we want it to be equal to beep, beep, boop, right? So if it's not equal, reject the request. Otherwise, here, we want to authenticate. Okay, call object equals. So reject the request, we've seen that already. So we're going to shamelessly copy-paste. Don't do this. Think about writing your code before. All right, amazing. But I'm on stage. I can do whatever I want. Ha, 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 ha. Robot. Right, there we go. Emojis, very important. You are not Mrs. Robot. So if you send me xRobotSecret and not be boop, you're not Mrs. Robot. Otherwise, then we're going to authenticate. So we need an authentication object. So we're going to create a robot authentication token. By convention in Spring Security, the authentication implementations are called authentication tokens. You can call them whatever you like. It's fine. And so this must implement authentication. So if we do this, authentication. Hello, JetBrains. There we go. I don't know what is happening, but it's fine, it's fine, it's fine. There we go. Class. The import is weird. There we go. So if I do this, I have a bunch of methods to implement. If I don't want to think about it too much, we have a higher level abstraction for this, the abstract authentication token, less methods. Needs a constructor, because I need to know the permissions of the user, or the entity. So here in this case, we're going to say authority utils. Let's say this one is role robot. So get credentials, I said credentials would be null, so leave them at null. In principle, it's the details about the request. I'm just going to give a string here. I could have a more detailed object, but I don't really care. I just want to grant access. And the last thing is I want to make sure that is authenticated is true. So one thing I can do is I can do set authenticated true. But another pattern we try and follow now in Spring Security is to make our objects immutable. So instead of doing this, I'm going to take everything that is about authentication. So authentication, these two. Is authenticated always returns true, because it's a successful request. And then if someone tries to modify it, I'm going to throw a new runtime exception, and then maybe some music, and maybe you can't touch this. Dun, 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 dun. Right. OK, so we have our authentication, and then we want to use it in the filter. So we have an auth. We want to set it in the security context. The way to do it is create a new context. And then in this new context, we set the authentication to auth. And then in the security context folder, we set the context to the new context. Voila. So now, if the demo gods are with me, let's try it. We try and get the private page. And we say xRobot secret is beep boop, right? So I get the private page. It tells me you're in the VIP section. Hello, Mrs. Robot. If my SREs get the passwords wrong or the secrets wrong and they put beep beep, then you are not Mrs. Robot. Amazing. Again, we have a little problem. Our users are not going to be super happy because when they go here, they try and go to the main page. It tells them you are not Mrs. Robot. This is true. I am not Mrs. Robot. I'm Daniel. And this is happening because my browser is not sending the header. And this is where the whole do you want to apply this filter thing comes in here. We only want to try and authenticate a robot request if there's an xRobot secret header. So request get header names. Wrap that in a collection, a list, so we can call contains on it. Contains, so if it contains xRobot secret, so if it doesn't contain, I don't want to protect or authenticate. So if there's no xRobot secret, what do? We call the filter chain, do filter, request, response. And we return to make sure that we don't apply the rest of the filter. So this kind of looks like the CSRF filter, right? We decide, we apply, sometimes we reject, sometimes we create an authentication object. And now, yes, I am not Mrs. Robot. I can use username and password, it works. But my SRE team has a secret they can use to access my private page. One thing that has changed in Spring Security 6 for people who have been using 5, in the past, when you did this, it would save that context and give you a session cookie, and so the user would stay logged in. It doesn't happen by default anymore for timing, race condition reasons. So if you want to save this session, this security, this authentication in your session, you will need a session repository, the HTTP session, or like basically a security context repository, right? A CR here. Nope, I want to import it. And so in here, you can save it. So you can save the context, request, response. And so this, by default, is going to be new context, it's called, sorry. This, by default, there's an HTTP session request repository that you can use if you want to persist login across requests. All right, so recap. Some filters, they do exploit protection. Some, they produce authentication objects. So they read the request, they check the credentials. If the credentials are valid, they create an authentication object and they save it to the security context. If the credentials are wrong, then they reject the request. So they throw a 4 or 3 or something. And remember, please, when you send me your reproducer projects, I do not want to see username password authentication token. You can do better than this. I trust you. OK, so we've seen the two most important concepts, right? HTTP interaction and then the domain language of Spring Security. The last one you want to remember is the authentication provider abstraction. So you remember I told you the authentication implementations, the is authenticated always returns true, and then credentials are always null. That makes no sense. We wouldn't keep those properties if that was always true. That's because I simplified a little bit, or lied, I don't know how you want to call it. Authentication objects, they're more than just a representation of a logged-in user. In Spring Security, they're used for two things. They're either a bag of credentials that I want to authenticate, or the result of a successful authentication. So if we take the use case of username and password, this transformation from the username and a password to an authenticated authentication object happens in an authentication manager. And so the way it happens is Spring Security reads the request, and it will create a username password authentication token that is not authenticated, that contains the username and the password, but it doesn't contain my email or my birthday because I'm not logged in yet. It needs to check the password. Then it passes that to authentication manager.authenticate, which is going to check against the database or against in-memory in this demo here. And if the user exists and the password is correct, it produces an authenticated version of username password authentication token. And in that authenticated version here, I have more than just the username. I have the user details, my email, my birthday, my fruit preferences, my roles or authorities, and then is authenticated as true. If something is wrong, for example, the password is incorrect, or the user doesn't exist, it's not in my database yet, then the authentication manager rejects the request, and it throws a authentication exception, can't authenticate. There are multiple implementations of the authentication manager. The one you need to care about is the provider manager in Servlet. So the provider manager is a glorified list of authentication providers. And authentication providers is a kind of a specialized use case of authentication manager. It has this authentication method, but it only deals with like one type of authentication. So you can reason about the different authentication flows in their own classes. So they have an authenticate method that can produce a successful authentication, an authentication exception. Oh, the account is locked, so I don't want you to proceed further. Or null. Sometimes you can say, I don't really know what to do with these credentials. Maybe someone else, maybe some default in Spring Security knows what to do with them. And so you return null. And here, it's a list. It's not a chain of responsibility, just like we see in the filter chain. It's just a list. So let's do a use case for that. We have an amazing app. It has 2 pages. I can log in 2 ways, and then the SREs can check the private page. Great. But now we need an admin to administrate these 2 great pages. So we hired someone, great guy from Paris. His name is Daniel. You know, he's funny, has a beautiful hair, a nice t-shirt. I like him, but he has very, very, very poor memory. Daniel cannot remember his password, which is probably not great for an admin. So we're going to do what you should not be doing in production. Do it on the main stage, never in production. We're going to say, when Daniel comes in, just don't check the password. It's fine. You know, it's just your admin. Who cares about the password? So we could do this in a filter. But if we tried to do it in a filter, when you think about it, it's a lot of work. I have to do, this is the post request to log in. I have to read the body of the request, which has a username and a password. I have to split this and extract these 2 variables. And it's already done for me. So instead, what we do is we're going to work only in the authentication domain by implementing an authentication provider. So we have a Daniel authentication provider. Amazing. Implements authentication provider. OK. 2 methods. Support, which tells you which classes, which Java types we support. So here in this case, it's only when someone logs in with a username and a password. So only the username password authentication token class. So if someone tries to log in with Google, I'm not applying this provider. If I try and log in with a robot, I'm not applying this filter either, or this provider either. And so what do? We do our authentication check. So we do authentication, get name, and if it's equals to Daniel in here, right, then this is OK, and then I don't really know. So object equals here. So OK, we need to return a username password authentication token. So let's create a user. We could load it from the database, but let's create Daniel with password. I need to set a password here. It's ignored. It's going to be deleted, but it happens that this user builder here needs a password. So OK, fine. And it needs roles. So I'm going to say Daniel is both a user and an admin, right? Because that's why we hired Daniel. OK, I made a Daniel, and now I need to make it into an authentication object. So return a username, password authentication token, dot authenticated. Amazing. So it needs a principal, the identity of the user. That's Daniel. It needs credentials. Well, I told you they can be null. Anyway, they're going to be deleted, and I'm not going to check them because I'm producing a authenticated version of this. And then some authorities, which are the roles. I'm going to get the roles from this user object. So if it's Daniel, just log Daniel in. If it's not Daniel, well, I don't really know what to do here. I don't want to reject the request for other users. Only for Daniel do I do something here. Otherwise, delegate to whatever Spring Security does by default. So we have an authentication provider. We register it in the security config here. Authentication provider, new authentication. So it's called Daniel authentication provider here. The order matters, but your authentication providers come first. So you have the chance to do your own behavior before delegating to the rest of Spring Security. And now, to the greatest security demo ever, if I go to the login page here, and I say Daniel, all right, wait for it. Sign in. Hello, Daniel. Aha, I'm logged in. Amazing. But if I try and log in with another user, then I get back credentials, which is expected, right? Only Daniel has special access for admin roles. User, I need to use the real authentication provider, the real thing that loads the user from the database and checks the password, which is the DAO authentication provider in our case. OK, so this allows me to check username and password without having to worry about how they came here, which is great because if tomorrow there's another authentication scheme that produces authentication requests in the form of username and password, then by default, this provider will be used. So if tomorrow I apply HTTP basic here, right, that's shown, HTTP basic, that's for you, with defaults, right? Now, I can make HTTP requests here, AT private, and then auth is Daniel Spring IO is awesome, right? And so I get the private page. Hello, Daniel, and you're in the VIP section. If I do user foobar here, right, it gets rejected. And all of this, I didn't have to write any code for this to go and like read, you know, this authorization header and decode it and like, oh, it's basic, and so I have to base64 decode it and so on. I only work in the auth domain. And so I get multiple benefits from this. I get this, not having to touch HTTP, HTML, but also I get all the goodness, the security that's built into the authentication manager. I get events. I get observability. So we can do events, for example. Let's see here. So let's do a bean, right, of type application listener of authentication success event. And call it listener. Return new application listener, which is basically a lambda. So event, right? There we go. And it's Java, is it? There we go. No new. And in here, I can read. I can't type Java anymore. And here, I can read the event, and I can get the authentication. That's the auth. And I can print some stuff like blue. Logged in as blue. Of course, you remember the most important thing in emojis is the emojis in the most. Ta-da! And format this. So we're going to say auth.get name, and then auth.class get simple name, so we can see something, right? So in here, I get events when some people successfully authenticate. So if I do blah, 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 log in with Daniel, check. Then here at the very bottom, I should get Daniel logged in as username password authentication token. If I go to the main page here and I log in with Google, which should go automatically here, it says user 10666 and so on, logged in as OAuth2. So I have all the goodness of Spring Security by just looking at the credentials. So recap. The authentication object, or the authentication interface, represents both a bag of credentials that I need to check and the successful result of an authentication. This transformation happens in an authentication provider, which only operates within this auth domain. So I don't need to care about HTTP, I don't need to care about parsing requests, and so on. And the authentication provider is then in an authentication manager that leverages all of Spring Security infrastructure. Last thing, because we have 5 minutes, amazing. Configurers. So we've seen the 3 important building blocks. That's what you need to remember from this presentation: filters, authentications, authentication providers. How does that work in Spring Security, do you ask? So you could go to the reference documentation, but I guess if you're here, is that because you don't live in the reference documentation like I do, you can go and look at the code and find these concepts. So for example, this HTTP basic here, not with defaults, when I click on it, it shows me it uses an HTTP basic configurer. And when I look at this HTTP basic configurer, in the Java doc, it tells me I'm going to create a filter called basic authentication filter. So if you want to learn how HTTP basic is handled in Spring Security, you can go into the basic authentication filter, and then you can see what it does. Oh, it converts the request, which is done by, I don't know, parsing the authorization header and doing a bunch of things. So if you want to change how this is done, if you want to change the name of the authentication type, then you can change this authentication converter. Same for OAuth2, for example. OAuth2 login here has an OAuth2 login configurer. So, it has filters. It will tell you what configuration objects you can pass. And if you look in the code authentication provider, you'll find our friend's authentication provider, the OAuth2 login authentication provider, and here, the OIDC authorization code authentication provider, which you can check. When is this used? Well, it depends on the scopes, if there's OpenID or not, and so on. And so you can go and start extending this as long as you understand the security protocol underneath it. All right, that was a lot of content in 45 minutes. So let's wrap up. We use filters to make security decisions on HTTP requests. Read the request, sometimes write to the response, sometimes not. Being logged in means providing an authentication object. That's the domain language of Spring Security, and it uses this authentication to do permissions. Producing these authentication objects is happening in authentication providers, which take the credentials, validate them, and produce a new authentication object. And when you want to implement cool custom login, you do a filter plus an authentication provider, which we don't have time to do here. But if you go to the repository, there are more steps to this demo. And each step is in one commit, so you can see the different steps, and it's explained. So if you want to see a little bit more how a robot thing could have an authentication provider, then it will be in the repo. Again, my socials, send me an email. I like it. You have crazy questions, and I learn a ton of stuff by interacting with you. With that, I thank you for your attention. Come grab me in the hall at lunch anytime, and thanks again.